than 5 hydrogen bond donors and 10 hydrogen bond acceptors, or when the molecular weight is greater than 500, or the calculated log P is greater than 5. So for you to have a better compound, then you have to maintain those parameters. So these properties can be quantified through physicochemical indices, and thus can be calculated in silico, and the data used in silico screening of databases and libraries. Okay, next slide. So the second rule, which the study focused on, is the Vaba rule, which is similar to Lipinski. It also describes the physicochemical characteristics of compounds. But in this case, it only focuses on two things, which are the rotatable bonds and the topological polar surface area. So what Vaba rule says is that the rotatable bonds should be either equal to or less than 10, while the polar surface area should be less than or equal to 140 angstroms. But optimally, it is recommended that it should be between 110 and 140 angstroms. While optimally, the rotatable bonds, which have the best quality, is at 7. So the effect of rotatable bonds, of course, is going to affect how your compound is going to interact with the target site. For example, in the example of aspirin, it interacts with COX-1 and COX-2. So the amino acids of COX-1 and COX-2, for it to interact with aspirin, the rotatable bonds are very important. Reason being, the rotatable bonds, if there are many of them, they are going to hinder the binding of aspirin to the active site. And so you have to minimize the number. And then the topological polar surface area looks at the surface area of all the compounds that are in, not the compounds, but the functional groups, for example, OHs that are found in a drug or in a compound, all of them. So the surface area of all those compounds. And as I mentioned, the polar surface area, which makes a compound, if it is more than 140, it makes a compound to be more hydrophilic. And if it is more hydrophilic, then it's not going to be able to pass through the lipophilic membrane that easily. So any drug or compound that does not adhere to these rules may have poor solubility, poor oral absorption, or less passage into the brain via the blood-brain barrier. And then, of course, eventually, this is going to affect the drug's bioavailability at the target site and also the action and the effectiveness of this drug. Next slide. Good. So the aim of the study is using the Osiris data order software, which allows us to be able to plot the graph of Lipinski and Vaba rule, and then you can be able to visualize, using this software, the physicochemical properties of these derivatives. So this Osiris data warrior software allows you to calculate for you the mentioned parameters, that is like the molecular weight, the C log P, and then gives you in the form of a graph. So the compounds that we analyzed were aspirin itself, acetaminophen, and the 11 aspirin derivatives, which I'm just going to show you in a few slides. Okay, so those are the compounds that were studied, basically from aspirin. As you can see from those compounds, the structure of aspirin is like the common denominator in all of them. So we have aspirin, and then we attached various functional groups. And then we put those data inside the series data warrior and be able to analyze them. So starting from the first rule, which was, as I mentioned, was the Lipinski rule. Next slide. So on the graph, you can see you have the total molecular weight. Then we have the hydrogen acceptors and C log P. And then those red dots as the molecules. So, for example, the total molecular weight, you see the scale from 0 to 500, and you can be able to observe that all the compounds are within that scale. When it comes to log P, on a scale of 0 to 4, all the compounds are within the required parameters. And also for the hydrogen acceptors, you can see also all the compounds are within those required parameters, which points to these compounds being very good candidates to be used in drug development. The next one is the Vaba rule graph. It gives you the molecular weight at the number of rotator bonds and also the sum of hydrogen acceptors and hydrogen donors. So you can see back. Okay, there. So you can see, for example, in the polar surface area, you have the scale of the polar surface area supposed to be less than 140. So you can see of each of the molecules, the polar surface area is within those parameters. Okay. Next slide. So one thing to note is that according to the Vaba analysis, we noted that 3 compounds, that is phosphoaspirin, where we have a phosphate group attached to aspirin, glucose aspirin, where you have a glucose group attached to aspirin, and ACS14 did not obey the Vaba rule. And this lack of, or this violation of the Vaba rule translates to poor absorption and poor bioavailability, which obviously will going to translate to poor effectiveness of these compounds. But as I mentioned, all the other compounds, when studied under the Lipinski rule of 5, all of them were able to show good characteristics which translate to them being able to pass easily through the phospholipid membrane. Okay, next slide. Right. So as I conclude, this data that we obtained from the CITES data area, when compared to data that is found in literature, you'll see that it gives you almost similar data, which means that this program is a very valuable tool that can be used for assessing the activity of potential drugs or for screening libraries when during our drug development. So the use of this computer software for screening compounds is very useful in drug development, as it tries and reduces or narrows down the study of new compounds, which then can be tested in the lab and also using lab animals. And those are my references. Thank you so much for listening to me.
Thank you, Frank. A better round of applause, please. Yes, that is a lot of complicated science. Let everyone do their thing. But thanks, Frank. You are clearly, Frank is a student in the School of Pharmacy. And you can see that he's clearly on his way to becoming a great scientist. So we wish you well, Frank. This session is supposed to be moderated by Miss Valerie Suge. When we started, she hadn't arrived, but now that she is here, I would like to invite her. I would like to invite her to continue with the moderation. The next presenter is supposed to be Justina, the Dr. Justina, and she had sent a poster, but I am informed that Frank is likely to be the one making this presentation. But Frank, you may want to make that confirmation as Ms. Valerie proceeds with the moderation session. Let's appreciate Madam Valerie as she takes it up.
Good afternoon, everyone. And good afternoon also to our viewers who are joining us online. As we continue with the session, I wish to thank all of you for making time back. And we're just going to confirm our next presenter, that is Justina. Justina, if you're there, you can kindly confirm to us you're there. Justina is going to be taking us through the analysis of selected physicochemical parameters of the coumarin derivatives as potential drugs in the Parkinson's disease.
Hello, can you hear me?
Yes, we can hear you, and thank you so much.
Hello, I prepare my poster.
Yeah, kindly share it, and then you can be ready to begin. Justina, you can hear us?
Yes, I can hear you.
Great. Your poster is up.
Yes. Now, hello. Can you see my poster?
Yes, we can.
Okay, so good afternoon. My name is Justyna Pankowska. I'm a student from Nikolaus Copernicus University, Collegium Medicum in Bydgoszcz, in Poland, in Europe. It's really nice to see you all, and
Recording in progress.
And I'm really glad that I can participate in this conference. I would like to say something about Parkinson's disease, because it's the second most common neurodegenerative disease in the world. And according to that WHO, Parkinson's disease affects more than 6 million people. And probably in 20 years, it's gonna be twice as many. And that's why the topic of my work, our work, was to investigate that substances of coumarin derivatives as potential drugs for Parkinson's disease. Because it's a really main problem in our lives in this century. And now we can see that the treatment is only decrease the symptoms this disease, and we're trying to find some medicines to really the cure for that disease. That's the main reason. And that's why we find some coumarins, and the derivatives are maybe possible that in the future it's gonna be the drugs for Parkinson's disease. And on my poster, we can see that we use the methods like Swiss ADME and Osiris Data Warrior. And we use the Lipinski and Weber rules. We see this on the first graph. And the red points, it's the drugs that we use now. And for the treatment, they decrease the symptoms, but not they are not the cure. And the black the blue points, this is the substances coumarin derivatives, which we search and we use for that research. And we can see that these studies gives us the green light for further search for the substances of coumarin, like potential drugs, because these substances are I'm sorry, a little bit nervous. They gave us the good results and properties for the future. On the down graphics show our Swiss ADMA, where we can see that the boiled egg plots and the white the yellow one shows us molecularly predicted to be passively penetrate through blood-brain blot, and the blue points as effluated from nervous system. And the analyses were carried out according to the Lipinski, Weber, and Swiss ADMA rules. And based on that conducted research, it can be observed that coumarins could be very most promising substances that will become drugs Parkinson's disease. We use 60 substances in this research. And it can therefore be seen the coumarins are a very promising group. And the conclusion is that on the basis of the obtained result, it was noticed that the test substances have similar physicochemical properties with drugs and differ with slight deviations. It can be the main point that the substances are similar and they could be have the similar in the treatment. Based on that analysis performed, it can be observed that coumarin are the most promising substances that will become drugs in Parkinson's disease. Thank you.
Okay, thank you very much, Ms. Justina, for that good presentation. Our next presenter will request that you can hold on a bit. We can have the next presenter and then we will take the question and answers. So our next presenter will be Pauline. Pauline, are you amidst us? Paulina?
Yes.
Great. So if we have Paulina, we would request that you can take up the next presentation.
Paulina, okay. Paulina is coming. 1 minute.
All right. Thank you very much, Paulina. So we will have Paulina's presentation, and then we will take the question and answers session for the three presenters. Welcome, Paulina. You can start your presentation.
Welcome. Am I audible?
Yes, you are. Thank you.
Okay, thank you very much. The topic of our presentation is the toxicological properties of potential antidepressants, and it's an in silico study. Something about me, maybe I'm a final year student of pharmacy faculty in Nicolaus Copernicus University in Torun. The Collegium Medicum is placed in Bydgoszcz. It's in Poland, Central Europe. And our team focused in the study on antidepressants. Depression is a condition which affects millions of people worldwide. It's an emerging problem within developed countries, due to the rising resistance to ongoing treatment options and some other options which are not strictly therapeutic, like medications, but more like vagus nerve stimulation, phototherapy, psychotherapy. So this urge pushes researchers to this field to discover more and more substances of potential antidepressant activity. So as it's stated, it's in silico study. And the aim of the study was to determine the pharmacokinetic properties of these molecules, which were precipitated from 2 publications. And the next step was to determine toxicological profile. And of course, comparative analysis between these substances investigated and already registered in treatment were conducted. About material, our material was made of 28 molecules, 7 molecules from paper delivered by Kayaulin. It's named as a group A with Roman numbers starting from 2A to G, actually. And the second paper, which is much less homogeneous in terms of molecular structure, is named as a group B. There are 21 compounds. In this publication, there are much more compounds, but they present activity and are both registered drugs and also an experimental ones, which are not going to be registered anyway. So these 2 groups and something about the first group is very homogeneous in terms of structure, because there are triazole 1 to 4 ons derivatives with some small differences in structure. First thing was to generate SMILES codes for each compound in HemSketch freeware software. That's an input data. And it helped us with conducting next analysis, starting with Swiss ADME. And Swiss ADME was for determining basic pharmacokinetic properties. So it is water solubility, blood-brain barrier passage, pig glycoprotein potential affinity, and lipophilicity. So as it's stated in the figure 1, the egg plot was generated with using Swiss ADME. The yolk, the yellow place shows the compounds which are probably able to pass this blood-brain barrier. But as we can see, withdrawing compounds on this stage is quite dangerous, because there are many other drugs affecting serotonin uptake, reuptake transporters or receptors that will not suit in this yellow point, but the white one. So it's just a matter of showing our results. Next thing was to determine the compliance of rule of 5 developed by Lipinski and other rule called Weber's rule, as it was stated in previous presentations. This data was obtained by putting compounds, both registered ones and this experimental, to Osiris Data Warrior, which played a part with generating 3-dimensional charts, as seen as a figure number 2. It's an example of parameters of compounds of group B and registered medication depression treatment. Different shapes and colors were applied. And the last step was to determine the toxicology analyzed compounds. and it was assessed with ProTox2 software. In terms of results, few compounds didn't meet the criteria of passing blood-brain barrier, but maybe some conjugates with other substances would help passing them this barrier. Few compounds, namely 3 of them, were assigned as poorly soluble in water, which may induce some problems in forming in drug technology. So the drug formulation for antidepressants is likely a tablet, so forming something which is meant to be quickly soluble in water may be a problem with these compounds. Lipinski's rule wasn't, the criteria for Lipinski's rule weren't met within four drugs, namely only from the group B. Group A is much better in this field, so they seem to be better candidates. Weber's rule, all the examined substances pass this criteria, and in terms of toxicity, it's the most important part. The compound 2F from group A was classified as the safest among this group. It's interesting to say that all of these compounds from group A were safe, relatively safe, with relatively highest lethal dose, but it's not only the thing that this class of toxicity proposed by the software is the most important thing. As it states, compound number 21 was classified, for example, as class number 2 with potential lethal toxicity after swallowing, but presents none of the toxic parameters. What are toxic parameters? For example, mutagenicity, and three compounds, 4, 10, and 13, were classified as potential mutagenic, which is something to avoid in terms of synthesis and projecting new candidates. And some of them express other receptor affinity, like estrogen receptor. Number 4 is also a potential carcinogen, a mutagen and immunotoxic. And immunotoxicity within group B is a quite common phenomenon, but of unknown severity. And some reactions may be very severe and some of them not really, but the software doesn't provide this information. And we have precipitated few compounds of potentially ideal antidepressant candidates. And from group A, there are 2B and 2G. And from the second group is 1, 8, and 12, because they meet probably the biggest number of criteria necessary for further medications. So it's very important thing to say that computational chemistry plays a crucial role in developing new potential medicines because it's time and money saving, but it's only a guide, not necessarily the ultimate procedure drugs at this stage. We also have to remember that this is only a freeware tool, not the commercial one. So the further analysis are needed. Thank you.
Hello, Paulina.
Oh.
Paulina, we lost you. Looks like Paulina has dropped, and probably as we wait for her, she's back.
I'm sorry, can this question, if there was a question, because I didn't hear it, can it be typed in the chat?
Sorry, had you finished your presentation? Had you finished your presentation, Paulina? Paulina, you can hear us?
Yes, I can hear you.
Had you finished your presentation? Did you finish?
Yes, I have finished my presentation. I'm sorry.
It's all right. Great, thank you very much. Let us applaud Paulina for the good presentation.
Thank you.
Thank you very much. We also request the members on the online platform to do their appreciation with the use of the emojis. We also would like to appreciate Justina in another way. Let us do one clap together. Very nice. Thank you very much. And we appreciate also Mr. Franklin for the good presentation. Another clap. Very nice. Thank you very much for those very good presentation. I hope you have learned. Those of us who have joined us this afternoon, we are on the second session of the presentations on our 12th annual international research. We've had very good presentations, and at this time, before we invite the next presenters, we would like to take the questions and answers. I hope we have learned quite a lot. Myself, I have Lipinski rule and the Vibas. I hope you have been reminded. So at this point, I wish to take, first we can take questions, and then I'll request the three presenters to hold on there so that we can have the questions for you. Anyone from the members here and those of us who are online, we encourage you to also type in on the chat. Then we will be able to take them through the presenters. There is one question. There's somebody raising their hand. Kisoi, Mr. Kisoi, please, you can unmute and go ahead.
Okay, thank you. So my question is, my question goes to Justina Bangawafka, and I want to ask, I agree with her that PD, that is Parkinson's disease, is a serious disease, but also we have brain diseases which are more serious than PD, which includes dementia, not limited to Alzheimer's disease, among others, like even TIA, that is transient ischemic attack. So why only focus on this one, which is Parkinson's disease, and not the others?
Thank you very much. We can take another question before we give them opportunity to answer.
Okay, because the Parkinson's disease is my the treatment and the research for new treatment is the part of my work to finish the pharmacy at the university, and this disease is very interesting, and I met a lot of people in Poland because I work in pharmacy, and I could see how the disease is processing, that the symptoms are more uncomfortable for the people, and that topic was really interesting for me, and a lot of articles shows that people and some scientists are looking for a new treatment, new substances. That's why I choose the Parkinson's disease.
Okay, thank you.
Thank you very much, Mr. Kisoi, for the question. We can hear another question.
Hello. My name is Barasa Briston. I'm also a pharmacy student. My question is directed to Justina, who presented on the topic coumarin derivatives as potential drugs in management of Parkinson's disease. So my question is, Parkinson's disease, first of all, is caused by due to depletion of dopamine in the brain. So my question is, what is the receptors maybe in the brain that you're targeting with these coumarin derivatives, also due to their structure, or what is the probable mechanism of action that you are working towards in terms of discovering these new agents for management of Parkinson's? Thank you.
Okay, we can take another question before we allow Justina to answer. There was another hand here. You can bring it to Fred.
Yes, can I? The coumarins, we consider the coumarins because actually we research more the chemical substances, but the coumarins gave us the most attractive results, and the coumarins they act like the medicines which we use in treatment today, but I need to say that the lots of substances which we research and we compare, they use the inhibitors MAO-B or some dopaminergic. So coumarins probably act like the same with this medicine we use in treatment now.
Thank you very much. We have another question. Thank you for that.
Thank you. Actually, my question is almost based on the same thing that the gentleman has asked. I was wondering, we already know that Parkinson's disease is caused by degeneration of nucleuses that are found within the basal ganglia. Now, and we already know that these coumarin derivatives are drugs which are already used as anticoagulants. So I just needed her to clarify, like, where is the relationship between the two, and what actually was she targeting by using a drug which is already used to try and manage Parkinson's. We know that Parkinson's, these are degenerative diseases of the basal ganglia. So I just wanted perhaps her keenly to show us where we're having the relationship and what is she basically targeting. It's partly what the other presenters asked, the mechanism specifically. You're using a drug which is already known, and you're trying to manage a condition in which you have the basal ganglia affected. So exactly where is the connection? I don't know if I was clear.
Yes, you are. We can request Justina.
We didn't hear a lot of most of the question.
All right, I can repeat. My question is, you are working on, you're trying to use coumarin to be able to find ways in which you can be able to treat or manage Parkinson's disease. So coumarin derivatives are already known that these are anticoagulants which are established. And Parkinson's are these are degenerative diseases which are caused by degeneration of nucleuses of the basal ganglia. Now, keenly, perhaps, would you tell us perhaps blood-brain barrier, but what else keenly are you targeting with your study?
Okay, so if I understand it, the first process to research that treatment, we just can. It's the first step, maybe. It's a first step. That's just the theory and use some programs, computer programs, which show us the pharmacokinetic and pharmacochemical properties. They are similar to the medicine which we are used now. So we can't say that it's gonna be a good drugs for Parkinson's disease, but they can maybe in the future, but we need more research. Now we are on the first step to research and to understand how they act with our body and with the inhibitors in our bodies. So we need more research, maybe in the future. That's the beginning of the research, the coumarins.
Thank you very much. We have another question from Dr. Kevin. Go ahead.
Okay, my name is Dr. Vincent.
Oh, sorry, Vincent.
Thank you. My question goes to Mr. Frank, and to some extent, Justina. But before my question, I want to commend my student, Frank, for your efforts in participating in drug development, drug discovery, trying to discover new agents for management of diseases. I just want some more clarification on what is the role or what is the place of Limp-Basic rule of 5 in modern drug design and development, considering that most of the drugs which are in use or which are being discovered do not conform to the rule of 5. And also, when you look at modern formulation, we are now focusing on use of nanocarriers, which are able to basically change or alter the pharmacokinetics of drugs and not necessarily the properties that were stipulated by Limp-Basic. And even most of the scientists are now going beyond the Limp-Basic rule of 5 to focus on molecular interactions, to look at the receptors, to look at the ligands, transporters, how they can carry these drugs in the system. So is there a place for this rule of 5 in modern drug design and formulation? Thank you.
Thank you. We can give the opportunity to
Thank you very
Franklin.
much.
Okay, if I did get the question right, you say that most of the drugs that are into market as of now do not conform to the Limp-Basic rule of 5. As I'm quite sure you know is that there are quite different or many ways of obtaining new drugs, and Limp-Basic way is one of the many ways. So the role of Limp-Basic, for example, is, as I mentioned earlier, is for in silico screening, which means you have numerous compounds which you suspect to have activity against a certain disease or a certain enzyme or a certain protein, for example. So for you to be able to minimize the number of these compounds to a number that you can be able to do lab testing and also testing on animal models, Lipinski rule can be used to reduce that number and give you probable candidates or candidates with best qualities. Also, to mention, there are drugs that have been obtained by using computer models, where you, let's say for example, you know of a specific site of action, like the COX one. If you can be able to isolate the specific amino acids responsible for activity, for example, then from that you can reverse that and make a compound that be able to target those sites. And from that you can be able to get a chemical compound. And then there are softwares which can be able to give you modification of that compound. And that is where the Lipinski rule and the other rules come in helping you narrow down the specific compounds that you can be able to study and also to get to your final product. Thank you.
Great. Thank you very, very much for that interactive discussion. Unless we have any other question, I don't see a question online. I also do not see another question. We sincerely want to thank members who have done those very good presentations. A lot on drug safety as we are looking towards bridging the gap in global health. At this particular point, I wish to then request all of us to have another round of applause for the three discussions. And to then invite my other facilitator, Dr. Vincent, to take over in the next session. Thank you very much.
Good afternoon. We want to move to the next set of presentations. I want to encourage or urge the members online and those attending physically to just keep on. We are getting a lot of information, a lot of science. I hope you are enjoying and having a good experience. So at this moment, we want to have presentations from Fred. Fred is going to present on a narrative review of the prevalence of obesity and its associated factors among adults. So we want to...
There is a student who is online called Ashna. She'll just be able to share her screen. I think she's already sharing. Ashna Patel.
She's the one presenting.
Yes, yes. So it's Ashna Patel from Prevalence. Okay. So you'll get the name.
Thank you for that clarification. I've been informed that it was a paper that was done together with Ashna Patel, and she's the one who is going to present. Ashna Patel, We can see your screen.
Thank you.
We want to welcome you.
Enough?
Yes, we can hear you.
Okay. So good afternoon, everyone. My names are Ashna Patel, and I'm a finalist upgrading student at Kabarak University. And I'm glad to have had this opportunity today to present at this conference. So my topic is on narrative review of prevalence of obesity among adults and its associated factors. So the authors were Mr. Dominic Vasco and Mr. Frederick Otieno. So the World Health Organization defines obesity as abnormal or excessive fat accumulation that presents a risk to health or that may impair health. Body mass index is a simple index of weight for height that is commonly used to classify overweight and obesity in adults. So we see that the body mass index is defined as a person's weight in kilogram and is divided by the square of his or her height. So also the WHO defines overweight as BMI equal or greater than 25, and obesity as body mass index of greater or equal to 30. So we see that recent studies have shown that there is a dramatic increase in the prevalence of obesity, and it's a major health concern worldwide as well as an epidemic disease in many developed countries. So obesity is said to have been associated with a large decrease in life expectancy, and the effects of obesity on the mortality rates is seen greater among the younger adults than the older adults. So recent studies have also reported that globally, more than 1.9 billion adults are overweight and 650 million are obese. So the WHO fact sheets 2021 also states that the worldwide obesity has nearly tripled since 1975, and that in 2016, 39% of the adults who were above 18 years were overweight, while 13% were obese. So it is clear that the rates of obesity is on increase every year as per to recent researches carried out on the prevalence of obesity. So this is a clear public health challenge given its association with increased risk of several non-communicable diseases such as heart diseases, cancers, type 2 diabetes, which is the leading cause of morbidity and mortality worldwide. So there are various factors that are associated with obesity, and they include physical inactivity. So with physical inactivity, we see that lack of money would facilitate no access to the physical activities. Then for nutritional choices, we see that today so many people try to make poor choices. So approximately 2.8 million deaths are reported worldwide due to consumption of energy-dense food and also living a sedentary lifestyle. Then also according to researchers and health experts of the United States, association of lack of financial support and obesity is due to poor families, where they tend to choose high-fat foods dense with energy, such as sugars, potatoes, cereals, then also processed meat products, since they are more affordable and they are long-lasting than fresh fruits and vegetables. Also, diseases such as hypothyroidism, insulin resistance, polycystic ovarian syndrome, and Cushing syndromes. Then genetics is also said to be a rare cause that can lead to obesity. Then medications such as steroids can lead to obesity. So other factors such as age, gender, marital status, average monthly income, and the duration of physical activities per day were also found to be associated with overweight and obesity. So obesity, being an emerging issue, has been one of the main medical and financial burdens for the government worldwide. So we see that little is known about the government action to implement food environment related policies, particularly in the lower and middle income countries. So this problem should therefore be emphasized as the prevalence keeps on increasing and will continue to worsen unless appropriate preventive measures are taken. So this review will focus on the prevalence of obesity as well as the impacts of the factors that are associated with obesity. And the major factors in this article include the nutritional choices that promote weight gain and physical activity. So methods, the data used to write this review article was collected from Google Scholar, PubMed searches which provided various internet sites for the articles needed. And then the Mendeley app was also used as a tool for citation. The publications to be included in the review were assessed for quality and consistency before inclusion, and the research was limited to publications in English language. So the discussion, prevalence of obesity. So we see that the increase in prevalence of obesity has become a worldwide major health problem in adults. So the World Health Organization also claims that obesity has more than doubled worldwide since 1980. And it's an epidemic disease in many developed countries and an emerging public health problem in developing countries. So particularly in the urban settings. So recent studies have reported that globally, more than 1.9 billion adults are overweight and 650 million are obese. Approximately 2.8 million deaths are reported as a result of being overweight or obese. So obesity in young adults is rising and predicts diabetes and cardiovascular diseases later in life. So on prevalence on gender, we see that studies have proven that women tend to be more obese than men, since most women tend to gain greatest weight during their childbearing, as well as we see that most of the women are housewives, unlike the. And this is also verified by Erem et al. That he verified that 33% of the housewives are obese. So according to age on the prevalence, most studies verified that the body mass index increases with age, and this was verified by a research that was carried out in Malaysia. That was the National Health and Mobility Survey 2. On geographic concentration, we see that obesity tends to increase with income in poor countries, and it has no relationship with income in the middle income countries and decreases with the income for rich countries. So obesity is further concentrated among richer groups in low income countries and evenly distributed in the middle income countries. So we see that in high income countries, the poor are the most obese. So As observed from various reviews, obesity in adults is rising and predicts various threats later in life. Therefore, data on prevalence and determinants of obesity in developing countries are needed for primary prevention. On physical so the impacts of factors associated with obesity. So on physical activity, the World Health Organization ranks physical inactivity as the 4th leading cause of global mortality, estimating that it results in 3.2 million deaths globally, mainly due to cardiovascular disease, diabetes, hypertension, and cancers. An active lifestyle helps to decrease the risk of obesity in both adults and children. However, a vast majority of adults in both developed and developing countries fall short of meeting the guidelines that are recommended for the physical activity. So public health researchers and obesity experts have blamed city planners for creating obesogenic environments, which is potentially fueling the obesity epidemic. So we see this obesogenic environment is an environment that promotes gaining of weight, and it's the one which does not is not conducive for the loss of weight. So this is an environment that has been defined as the sum of influences that the surroundings, the opportunities, or the conditions of life have on promoting obesity in individuals or a certain population. So we see that family income may also influence physical inactivity, as lower income people are less likely to meet the physical activity guidelines when compared to higher income people, and this therefore contributes to obesity. Then also, according to Roemich, he found out that residential locations closer to parks were associated with higher physical activity levels compared to those which were away from the parks. The characteristics and quality of various types of neighborhood built environment can noticeably differ between developed and developing countries, which may differentially impact the physical activity and obesity patterns among this among the local residents. So we see that the neighborhood built environment, so this is a neighborhood where people live in, they have a major impact on their health and their well-being. So therefore, possible barriers to physical activity must be determined and eliminated to promote active living and reduce the inactivity levels among the population, as well as adhering to physical activity guidelines. Hence, a decrease in obesity levels will be observed, as well as a reduction on the non-communicable diseases that are associated with obesity. So on the nutritional choices, obesity has become a very serious health problem, and a huge number of population is facing this problem as at now. Moreover, it is also a fast-growing problem throughout the world. There are various factors that are responsible for this problem, and overnutrition is amongst them. Many developing countries are currently undergoing a rapid nutrition transition, and this transition is characterized by changes in dietary habits and more sedentary lifestyle where no any kind of physical activity is involved, as opposed to an active lifestyle. And as a result, overweight and the obesity rates have increased. So while all segments of the population are affected, the food insecurity and low-income people are especially vulnerable to obesity due to the additional risk factors associated with poverty. Healthy food may be more expensive in terms of the monetary cost, whereas refined grains, added sugars and fats are generally inexpensive, and they're readily available in low-income communities. However, households with limited resources often try to stretch their food budgets by purchasing cheap, energy-dense foods that are filling, while less expensive, energy-dense foods typically have lower nutrition quality, and because of overconsumption of calories, they have been linked to obesity. So there is a need in the government. There is a need in the government involvement towards lowering prices on healthy foods and increase prices on foods that tend to put one in a risk of developing obesity. Also, promoting public awareness to people on the impact of consuming energy-dense food should also be encouraged, as well as establishment of effective policy interventions after understanding why people tend to make unhealthy dietary choices. So in conclusion, due to the above impacts of the factors associated with obesity, the rates of obesity tend to be on an increase. As such, public health policies focused on reducing and treating obesity must be developed. So possible barriers to physical activity must be determined and eliminated to promote active living, adhering to physical activity guidelines. Hence, a decrease in obesity levels will be observed, as well as a reduction on the non-communicable diseases that are associated with obesity. Also, there is a need in the government involvement towards lowering the prices on healthy foods, as well as implementing food environment-related policies. Promoting public awareness to people on the impact of consuming energy-dense food should also be encouraged, as well as establishment of effective policy interventions after understanding why people tend to make unhealthy dietary choices. Thank you.
Thank you, Ashna Patel. We request you to stay put. We are going to have a question and answer session at the end. We still have 2 more presentations. Our second presentation is by George Kisoi. George, kindly confirm if you can hear us. George?
Yes.
Thank you. Kindly, if you can share your screen. After George, we will have Dr. Nasir Sani. Dr. Nasiru, kindly confirm if you are around. Dr. Nasiru Sani, are you around? Okay, thank you. Dr. George Kisoi, you have your time.
Okay, so thank you for having me. I appreciate. My name is Kisoi George. I'm a student at JKUAT, and I'm presenting today a paper that is part of a larger study. And this is phylogenetic analysis of Acacia nilotica and Coffea arabica using this protein known as RBCL gene. So in addition to nuclear DNA and mitochondrial DNA, plants also have what we call chloroplast DNA. And because nuclear DNA is the one that is used for systemic botany less frequently than the others, then and also mitochondrial genome is used at a species level, then the next option is to look at this chloroplast DNA that is being used widely for evolutionary and phylogenetic studies. So we have this gene known as ribulose 1,5-biphosphate carboxylase gene. This gene is the one that is coding for an enzyme, and the name of that enzyme is known as Rubisco. And the Rubisco is the one that is utilizing some other factors to form what we call organic compounds, such as glucose, amino acid, among others, in plants. So this plant, known as Acacia nilotica, is being used by locals of Baringo County, largely from Baringo South, North, and parts of Samburu, to treat what you call ear infection, eye infection, also painful urination. And also, they are being used by the locals as a beverage. They make a coffee-like concoction. So apart from all that, it's also used to treat cancer and diabetes, among others. But the problem is that there is no scientific facts on the comparison of the evolutionary relatedness between these two plants. And the plant that I'm going to compare with is the one that we normally use, or other people are using it. And that is now the coffee Arabica variety. So the prolonged use of this plant can cause a long-term health effects, which, if not taken care of, can be of national issue. So, as earlier mentioned, this is a study that captures 4 points, and the first one was to quantify and qualify the phytoconstituents. The second one was to evaluate the levels of cavein in this Acacia nilotica subbalata subspecies, and also compare with Coffea arabica. And the second one is to establish the antibacterial activity of these plants, so that we are able to see, or rather to look at the activity against these bacteria known as Pseudomonas aeruginosa, and finally to look at the relatedness in terms of phylogeny between these two plants. So that is the focus of this paper, is number 3. So the data was collected from 13 different species, 6 belonging to Acacia, and then another 6 group coming from coffee, and 1 as an outgroup, because Acacia and coffee are in groups. And the information was obtained from NCBI. NCBI is the National Center for Biotechnology Information. So I did what you call, or rather the study focused on the sequence analysis, and this was done in plant species, that is Acacia nilotica and Coffea arabica, where the sequences of these 2 plants are always, or rather are available on GenBank. And the reason for that is to find the interspecies variation between these 2 plants. So there's this software tool that is being used, known as Muscle, and the editing aspect was done using JALView. So the phylogenetic analysis using maximum likelihood estimation and neighbor joining order is to look at the frequencies of this amino acid, and also look at the transition-transversion ratio. The transition-transversion ratio is a situation whereby the ratios between the purines and the the purines and pyrimidines. Purines, we are looking at adenine and guanine. So if adenine is replaced by guanine, that is a transition. But if guanine is replaced with thymine, and that is what we call transversion. So we are looking at that ratio, and also looking at the variability of where it has to be computed by this software known as MEGA7. MEGA is molecular evolutionary genetic analysis. We have by then we used 7, but now we have the latest version, that is version 11. So the sequences were done by MLE, and the MLE is the one that is being incorporated in this software known as MEGA. And the distances between these two, the distances between the branches, we are going to see that, or clade, is done using this method known as neighborhood joint method. The bootstrap value was also analyzed by this NJ plot. So these are the accession numbers for the sequences which were retrieved from the gene bank. So we have the 13 plant species, and one being an outgroup, and that is the 13th one. So this is a neighbor joinhood diagram, or rather tree that was generated based on the results, based on the section numbers, and you can look it from. You can see that we have coffee arabica, coffee resmosa, and coffee sulfatrix. Those are the coffee arabica and coffee resmosa, and of course it has the sisters, or rather the sister groups of this coffee arabica are resmosa and salvatrix. When we look at Acacia nilotica, we have the sisters to that, which is now cousins to coffee arabica, if you allow me to use that, and which is Acacia carew, Acacia nilotica itself, and then Acacia nilotica subspecies hemispherica, and then we have the Albizia labec. The others are also, they share the same ancestor, which happens to be the one that is shared by this outgroup known as the Triclas bacterium. The values you are seeing there is what we call bootstrap values, and scientists say that any value that is above 70 is significant, though that is something of debate, because other scientists also propose that any value that is above 50 is considered significant. So this is maximum likelihood estimation. It's still the same thing that I'm making comparison, or the study is making comparison with the various methods of constructing phylogenetic trees. So the same thing happens on that. You can see the values and also the branches. The branches, these are the plates. So it means that the coffee arabica and Acacia nilotica share the same ancestor, and when they share the same ancestor, they are monophyletic. And you can see any value that is almost nearing 100, it means that these two plants are almost close, or rather they're close related. But any plant that is having more than less than 70 or below 80, then the plant itself is distantly related to the species of interest, and the species of interest in this case is Acacia nilotica. So so this is also maximum likelihood, and when we look at the Acacia species worldwide, we have 1380, well, that's 1,380, but in Africa we have 130, and the taxonomy, according to Brennan, if you compare the Acacia nilotica subspecies suballata and coffee arabica, they only differ in terms of genuses, but they share the same family, order, class, phylum, and also kingdom. So in Africa we have nine subspecies of Acacia nilotica, and the subspecies we are talking about, one of it being suballata that is of interest in this study, or was. And of these 9, we have 3 are in India and 6 are in Africa. So they differ in size, of course, and the single-stemmed grows above 2.5, between 2.5 to 15 meters above the ground. Of course, the bark is what is of interest, because the locals are using this bark to make concoctions. Of course, not the dead part, but the live part, that is the inner part. And when the plant matures, the bark of this plant tends to become gray. So the suballata always flowers in two occasions, that is month of April and November, and the color of the flowers are always yellow, and as the pods ripens, as they grow, they are green, but as they ripen, they turn to gray. Of course, we talked about the bark, and the leaves are deathly hairy. And when we look at this chloroplast gene, which is a conserved gene across all the plants, So it is a gene that is almost that is dormant. So this is the gene that we get the sequences, the RBCL sequences of both the Acacia nilotica and Coffee arabica were assessed, so that the coding region of these RBLC genes or sequences were retrieved from the gene bank, as you've seen earlier, and we performed what we call the BLAST. And the BLAST search showed that these two plants are 95% sequence similarities with the multiple plants. So the performance was aligned, the sequence alignment was performed using this multiple sequence known as Chloroplast W. Chloroplast W is also incorporated in MEGA, that is molecular evolutionary genetic analysis. So the trees I'm talking about now, the Coffee arabica varieties and the Acacia nilotica subspecies suballata were conducted using these two methods, and they were phylogenetically related with Coffee resmora, Coffea salvatrix, and of course Acacia ladec, and finally Acacia nilotica subspecies hemispherica, and of course Acacia nilotica carew or Acacia carew. So we have the genes for this, the gene sequences of these plants, and the related taxa shows that the two plants is a bit distinct and also distant because of the clades, because the branching of the Coffee arabica occurred before the branching of the Acacia nilotica. So it means that the two are show a distinct lineage coming from a common ancestor, and also the two being sharing a common ancestor shows what you call monophyletic relatedness. That is, plants having the same having the same common ancestor. They originate from a given ancestor. So the purpose of this RBCL gene is to help determine the phylogenetic relationship of all kinds of plants that you would want to know, and whether they are distantly related or closely related. If they are closely related, how close are they? Are they forming sister groups? Are they forming distant sister groups or cousins? So the phylogenetic analysis complements and also the performs the similarity studies between plants, and also this software known as MEGA, which is an offline software which you can install in your PCs, is the one that can be able to identify protein sequences and also interspecies relationship. So these three analyses that we looked at shows that the Coffee arabica and Acacia nilotica originate from the same, have the same common ancestor, and that's why we are saying they are monophyletic. And our recommendation, or rather the recommendation of this study, is that further research or further work needs to be done on the analysis or the phylogenetic analysis of Camellia sinensis, that is T, Acacia nilotica, Coffee arabica varieties, and also Coffee robusta varieties. Thank you.
Thank you, George Kisoi. Can we appreciate? Thank you so much. So at this time, we want to go to the question and answer session. Are there questions in the chat? To our two presenters, Ashna Patel and George Kisoi. I want to welcome questions from the online audience and the audience physically present in the room. Any question directed to them? Maybe as I wait for the audience to ask their questions, I can ask a question. My question goes to Ashna Patel. Ashna, kindly confirm if you present. Ashna Patel. If you present, you can unmute and confirm. Okay, as we wait for Ashna to join, I can also ask a question to George Kisoi. Thank you for giving us information on the phylogenetic analysis of Acacia nilotica and Coffee arabica. And from your findings, you were able to tell us that they have a monophyletic relationship. I just want you to maybe to tell us, to elaborate, how useful is this information for us, particularly those of us who are in drug discovery, drug development? Is it important for us to know the relationship of the different species, the tree species that we use as sources of drugs?
Okay, thank you for your question. This study is very important because of the medical field, or rather, important to the medical field because of the phytochemical constituents that are found in these plants that can be of usefulness to treat so many ailments, including the ones that I've mentioned earlier. That is infections, various infections, including skin rashes. So the pharmacists needs to come and now do what we call drug design modeling and get to know the mechanism of these phytochemicals, and more so the specific phytochemicals, because we have a wide array of phytochemicals that are found in these plants that are of importance to health in terms of treatment of various ailments and diseases.
Thank you. I'm still waiting for questions from the audience. Just a follow-up question on that. What if the two plant species were not, let's say, do not have a common ancestor? Can we still use them as sources of drugs, or what can you recommend?
Sorry?
For example, if the two species were not from a common ancestor, could you still recommend them for maybe as sources of drugs?
If the two species were not of
from the same ancestor, or they are not monophylogenic, monophyletic.
Yes, yeah, I would recommend, because we treat each plant as independent of one another. In fact, the Acacia nilotica subspecies subelata has phytoconstituents that are rich, that are of medical importance compared to Coffee arabica. I'll just mention a few. You find that the levels of saponins, the levels of alkaloids, the levels of flavonoids, the levels of terpentines, the levels of there are so many phytochemicals that are the levels. I'm talking about the levels because these phytochemicals are also found in Coffee arabica, but the levels might be lower compared to that of Acacia nilotica. So if the level of alkaloids are a bit higher in terms of quantity compared to the other species or the other plants, then we can see the importance of these alkaloids in terms of treatment, or in terms of looking for drugs of interest for treatment of diseases. So I would recommend that if they are not monophyletic, if they were paraphyletic, then I would recommend that we treat each plant independently and look for these phytoconstituents and also that are of interest. Thank you.
Thank you, sir. A question from Dr. Kagia.
Oh, thank you, Kisoi, for the wonderful presentation. Just a quick follow-up. You retrieved the sequences from GenBank. I'm curious why you did not choose European Nucleotide Archive or the DNA Data Bank of Japan. I'm curious why you settled on GenBank and not the other two. Thank you.
I did not get the question. Kindly, pardon, repeat.
Oh, sorry.
You're asking?
You retrieved your sequences from GenBank.
Yes.
I'm curious why you did not retrieve them from the DNA Data Bank of Japan or from the European Nucleotide Archive, why you settled on GenBank instead of the other two databases.
Okay, thank you. So the reason why we retrieved the sequences from GenBank is because that is where now the protein, that is where the sequences for protein, not nucleotides and not any other, the protein sequences for various plants are reposited, or rather they are archived, as compared to when you are doing what you call when you are blasting, then you are able to get so many hits in GenBank compared to other sources of where other sources where data is being kept.
Thank you, sir, for the responses. I can't see Ashna Patel, but since the study was done together with Fred, I have a question. Thank you for giving us the statistics on the prevalence of obesity in the world. I'm just curious to know what is the current situation in our country in terms of the figures and maybe the associated factors.
Oh, thank you. I beg to I beg to perhaps answer you in a minute or two when Ashna is back, kindly.
Thank you. I don't see any other question.
Question,
yes,
please.
Yes. Go ahead.
Okay, so my question goes to Patel. She talked about obesity. Housewives being obese compared to men moving out of that house, or rather, whether I did get it correctly or not. The question is, does it mean that obesity begins at home? And the next question is that what is the relationship between housewife and obesity? Sorry if I got it wrong, forgive me. The third one is that if one is living in a house that has one room, because there were so many factors that contribute to obesity. So my question is, if one lives in a house that has one room, and another person lives in a house that has 6 rooms, or 12 rooms, or 20, or 10. So who is likely to be obese? Thank you.
Thank you, sir, for the question. One more question from Frank. Or can I see 2 more before they respond?
My question is also on the obesity. So I'd like to ask, how is the prognosis of obesity in a person who does